Given a two-dimensional grid, hash marks are stones, asterisks are fixed obstacles, dots are empty cells. Rotate the whole box 90 degrees clockwise. Then stones fall due to gravity until each one rests on another stone, an obstacle, or the bottom of the box. Return the final grid after rotation and falling. Example, 2 rows and 4 columns. Top row is hash dot asterisk dot, bottom row is hash hash asterisk dot. After rotation and gravity, stones settle in the rotated columns. The result is 4 rows and 2 columns, first row hash dot, second row hash hash, third row asterisk asterisk, fourth row dot dot. Picture the box from the side. After a 90-degree clockwise turn, stones fall straight down in columns. The trick: before you rotate, slide every stone as far right as it can go in its row, like wind against the right wall. After the turn, that wall becomes the floor. Now watch one full row scan, where J reads and low marks the next stone landing slot. Column 4 is a stone. J equals low, so the stone stays put and low steps left. Column 3 is empty. Only J moves left, low does not change. Column 2 is empty. Again, only J moves left. Column 1 is a stone. Slide it to low at column 3, then move low left. Column 0 is empty. End of the row scan. Now add a wall. When J hits star, low resets to J-1 and chambers pack separately. Column 4 is a stone on low, so it stays and low steps left. Column 3 is empty. J moves left, low holds. Column 2 is a wall. Set low to J-1, then continue left. Column 1 is empty. J moves left again. Column 0 is a stone. Slide it to low at column 1, then move low left. First pack every row to the right. Then rotate the picture 90 degrees clockwise, the short wide box becomes a tall matrix. Because the shape changes, you allocate a brand new n by m array and write each cell into its mapped position there. 2 passes. First, slide the stones right inside each row of the box. Then allocate a fresh n by m grid and write each cell into its rotated slot. Column 3 is empty. Move J left. Column 2 is a wall. Reset low to column 1. Column 1 is empty. Move J left. Column 0 is a stone. Slide it to low, then move low left. Row 1 is the same pointer logic and is already packed, so we skip the detailed trace. Pass 2, write the answer. Cell at row BR, column BC lands at row BC, column M-1 BR. The bottom row of the box becomes the left column of the tall answer, the top row becomes the right column. After all 8 cells are placed, the result matches the expected output. M is the number of rows in the box and n is the number of columns. Time is O of m times n, each pass touches every cell once, first sliding stones right row by row, then filling the n by m answer with the 90-degree clockwise mapping. Space is O of m times n for the output grid. We mutate the box copy in place during packing, then allocate the rotated result. Main routine: pack stones to the right within each row, then write the clockwise rotated grid. M is the number of rows in the input box. N is the number of columns in each row. The outer loop visits every row for the rightward slide. Low starts at the rightmost column as the next landing slot for a stone. J scans the current row from right to left. If this cell holds a stone, we relocate it toward the right wall. Clear the cell at J. Place the stone at column low. Decrement low so the next stone sits farther left. Otherwise, if this cell is a fixed obstacle, stones cannot cross it. Set low to just left of the wall for the next segment. Allocate the answer as an n by m grid matching the rotated shape. The outer loop indexes rows of the answer. The inner loop indexes columns of the answer. Copy from the packed box using the 90-degree clockwise index map. Return the completed answer grid.